Welcome back from the ad break, and then let's continue with our lesson. So let's focus more on those application questions. The first one here says, the kite below is given with AB is equals to 4 centimeters and BD is equals to 6 centimeters. The diagonals meet at J. Calculate. So let's start with the first one there, which is the length of AD. So now when we look at AD, it is an adjacent side to AB. And we know that with a kite, we have two pairs of adjacent sides that are equal. So whenever we are dealing with these quadrilaterals, we need to keep in mind the properties of that quadrilateral. So now, AB was given as 4 centimeters. And since as well in a kite, we have two pairs of adjacent sides, we can see that AB is adjacent to AD, and that is the side that it is equal to. So AB is equals to AD, which means that AD is also equals to 4 centimeters. And as our reason, we will write to say that it is an adjacent side. Adjacent sides of a kite are equal. Then next we have the length of DJ. So how are we going to calculate now the length of DJ? Let's look at where DJ is. Now DJ is part of a diagonal DB, and when we look at our information, we have been given the length of DB or BD, which is 6 centimeters. Now if that whole length is 6 centimeters, what do we remember about the diagonals of a kite? We know that the diagonal that is the axis of symmetry, in this case, that is AC. So AC is the axis of symmetry for this kite. And that diagonal that is the axis of symmetry will bisect the other diagonal. So in this case, AC is bisecting DB, which means that DJ is equals to BJ or JB. So what does this mean? This means that DJ is equals to half of DB. So this means that DJ will be equals to 3 centimeters. And that is because we know that the diagonal that is the line of symmetry, it bisects the other diagonal in a kite. Let's move on to the last question, and that is the size of DJC. So DJC, that would be now DJC, and that is that angle there where our diagonals meet. But what do we know about the diagonals of a kite and where they intersect? If you are thinking that they intersect at 90 degrees, you are absolutely correct. So that means that the size of DJC is equals to 90 degrees. And that is because the diagonals, or we can say there, that is because AC is perpendicular to DB. AC is perpendicular to DB, that is why DJC is equals to 90 degrees. Let's move over to the next question. Now the next question says there, a parallelogram below is given with PQ is equals to x plus 6, PS is equals to x, and SR is equals to 20 centimeters. Q is equals to 2y, not y, that is an error there, but Q is equals to 2y and S is equals to 82 degrees. Now calculate the values of x and y. So we are going to use the properties of a parallelogram to calculate the values of x and y. So which one can we start with? Well, firstly, we know that in a parallelogram, the opposite sides are equal. This means that a PQ is equals to SR. And our reason for that is because they are the opposite sides of a parallelogram. So PQ was given as x plus 6 and SR was given as 20 centimeters. Now, using the additive inverse of 6, then we are going to just say that it is going to be 20 minus 6. That means the value of x is equals to 14 centimeters. So that means that x is equals to 14 centimeters there. Then when we move over to another property of a parallelogram is that the opposite angles are equal. And in this case, we can see there that 2y, or let's start with the letters there to say that angle S is equals to angle Q. And the reason for that is because they are the opposite angles of a parallelogram. So now we have 82 degrees is equals to 2y. And if we use the multiplicative inverse of 2, or if we say that if we've got 2y that is equals to 82, what will y be? We know that y is going to be now half of that 82, and that is 41 degrees. And we did that by using the multiplicative inverse of 2, which is a half. So that means that y is equals to 41 degrees. Let's look at the last question of these application questions. So we have been given there, the rhombus below is given with AB is equals to 5 centimeters. So we have AB is equals to 5 centimeters. Then we are told that AC is equals to 6 centimeters. We are told that AC is equals to 6 centimeters. Then we are told that angle C is equals to 100 degrees. The diagonals meet at P, as we can see there, and then we are required to calculate the following. So we are going to calculate firstly the length of AD. Now when we look at AD, AD is one of the sides of this rhombus. Now, the fact that it is a rhombus, we know that all of the sides of a rhombus are equal. So we know that AD is equals to 5 centimeters. Now, why are we saying that? It is because we were given AB as 5 centimeters, and we know that AB is equals to AD, AB is also equals to BC, and AB is also equals to DC. So we can say that the sides of a rhombus are equal. So all sides of a rhombus are equal. Then next, we are required to calculate the value of x. Now, if we look at where x is, we can see that it is part of the angle that was bisected by diagonal AC. Now, we were given angle C as 100 degrees. But what do we know about the diagonals of a rhombus? Yes, they bisect the opposite angles. So this means that even though the whole angle is 100 degrees, it has been bisected into 2 equal angles, and that is 50 degrees and 50 degrees. Now, how is this going to help us? Well, this is going to help us because we can find the value of x using one of 2 ways. Well, firstly, we can use the fact that we know that in a rhombus, the opposite sides are parallel. Now, if they are parallel, that means that we can see alternating angles. And what do we know about alternating angles? Alternating angles are equal. That means that x is equals to 50 degrees, and we can say there that it's because of the alternate angles, and this is simply because AD is parallel to BC. That is just one of the ways that we could have calculated that. Another way that we could have calculated this, the value of x, is that we could have seen there that because of the 2 adjacent equal sides, so that is because of AD and DC. So because of AD and DC, they are equal, which means they form an isosceles triangle, and that is triangle ADC. And because of that isosceles triangle, we know that the angles that are opposite the equal sides are equal. So we already have 50 sorry, we already have 50 degrees, that is opposite side AD. This would also mean that the angle that is opposite side DC is also 50 degrees. And our reason for that would be that the angles are opposite the equal sides. Let's move on to the last question, which is the size of D. Now, the size of D, again, can be found here using many ways. The first way that we can use is that we can use the interior angles of a triangle. Again, looking at that triangle ADC, the interior angles of a triangle ADC will be equals to 180 degrees. So if we take the 50 degrees that is already in there, which is the X, plus the 50 degrees that we found there, which is the bisected angle there from C, and we add this to our angle D, that is going to be equals to 180 degrees. And the reason for this is that the interior angles of a triangle are supplementary, which means that they add up to 180 degrees. Now, of course, adding those like terms, 50 degrees plus 50 degrees is equals to 100 degrees. When we add that to D, it will give us a sum of 180 degrees. And using the additive inverse of 100, we have angle D is equals to 180 degrees minus 100 degrees. That is going to give us D is equals to 80 degrees. So angle D will be equals to 80 degrees. Of course, we could have used co-interior angles. Remember, we have that angle as 100 degrees, which is angle C. And if we have angle C as 100 degrees, if we combine it with angle D, it must give us 180 degrees. And from 100, for us to get 180 degrees, that means that angle D is equals to 80 degrees. Let's quickly go to an ad break and then we'll see you just now.